Few more things. A forest fire. So, what does a forest fire do? 165 million tons of CO2 equivalent was the Australian forest fire of 2009. There are some assumptions about the area that was covered and so on and so forth, but you get the idea. 231 million tons of CO2 equivalent for the Californian forest fires of the summer of 2008. Forest fires are an issue, and people look for trends in them in terms of just the number of fires, the intensity of the fires, the area that's burning, and so on. So there is the additional factor of humans managing forests or even using preventive actions to reduce the number of fires. So they are not so wild anymore. There is a lot of human intervention happening, even though lightning is often the cause for starting the fires. I should put this in display mode and talk about it again. So Australian fires were equivalent to the total yearly footprint of more than 5 million Australians or 50 million Chinese people. So you can see the difference in the carbon footprint per person over there. Again, there are other details in terms of what feedbacks go on. For example, the book provides this simple idea that climate change creates drier forests and brush fires and then CO2 emissions. A more sophisticated picture is given by World Resources Institute, where rising temperatures create drier conditions in forests, milder winters that lead to lower snowpack, higher pest populations, and longer fire seasons. So fire seasons have definitely become longer. Larger burned area from fires result from more dried out dead vegetation, which acts as a tinderbox of fuel that is easily sparked by lightning or people. So this is also well known from scientific research. Emissions from fires increase as they burn over expanded areas longer and more frequently, so that increases emissions. More carbon in the atmosphere accelerates warming and leads to temperature rise. So fires can become large enough to create their own weather and then begin to have a positive feedback as well. So this is just some data. Estimated carbon emissions for the period of June, July, August for Western USA in the years 2003 to 2021. This is showing you the interannual variability and for a particular season or annual cycle of forest fires. So total wildfire emissions in megatons, 10 to the 6, and you can see that there isn't necessarily a trend here. There is large interannual variability, but then you have years where they have had fires that just jumped out of the scale in 2021, for example. And this is CAM's daily total fire radiative power for Western US during June, July, August. Tells you just how deadly and how hot and the fires can be, and in fact the emissions can reach far, far away, all the way to the eastern coast. Canadian fires come down to the DC area in terms of their emissions, and so on and so forth. This is another figure showing carbon emissions from fires in California in teragrams. So the 2020 data here was preliminary data, but the same message that there is large interannual variability. Why particular years jump out is not always exactly clear. Okay, so forest fires are a big source of emissions to the carbon inventory, and can be much larger than 1 million tons. Looking at country per country emissions, we looked at per capita emissions, so this is just combining that. So here we are again starting with Malawi, around 1.5 million tons of CO2 per equivalent per year for Malawi. Numbers go up for Iceland, Australia, France, UK, Canada, Brazil, surprisingly very high, Germany, India, is high: Russian Federation, China, and the US. So again, as I said, European Union wants to be one unit for certain things, but split into countries for other things. So they always want to count emissions by country and not as a European Union, which puts India as the third or fourth largest emitter, as opposed to taking European Union as a single unit. So if you just focus on the UK, a breakdown of the UK's carbon footprint, including imports but excluding exports. So when there is trade, we have embedded carbon. So where do you count the carbon? At the place where carbon was emitted, or at the place where the product was consumed. This is always a big issue. We'll see another map of it. We already discussed. Without going into details, you have household fuel, consumer vehicle fuel, household electricity, consumer air travel, other consumer transport, motor vehicles, food and drink from retail, hotels, pubs, catering, paper and printing, textile and clothes, electronics, computers, appliances, construction, water and sewage, defense, education and health, and social services. So obviously you can go into lots of details. Uncertainties are not always mentioned, but nonetheless they can be important. But the general magnitude, order of magnitude relative to the global mean and each country is always fairly reliable. Looking here again at global greenhouse gas emissions from all sources for 1970 to 2020 gives you a good sense of where most of the emissions come from. Not surprisingly, when you look at global greenhouse gas emissions in gigaton CO2 equivalent, so you convert non-CO2 gases into the calculation as well, using the greenhouse warming potential, etc., that we talked about before. Fossil fuels are the biggest culprits. Then you have land use, land change, forcing of CO2, methane, which has all kinds of variabilities over time that are not always fully explained, N2O, and fluorinated gases that come from various sources and are strong greenhouse gases as well. If we look at cumulative emissions from 1850 to 2021, this is in billions of tons of CO2 from fossil fuel, cement, land use and forestry. United States tops the charts, with most of it coming from fossil fuel burning and some coming from land use and forestry. China is second, but you can see it's much lower. This is at just over 500 billion tons, and this is just under 300 billion tons. Russia, Brazil, Indonesia shouldn't be way up here, but they are. Most of it coming from land use change, unfortunately. Germany has negative land use change because it has either afforested or created sinks somehow. India, UK has no land use change emissions. Japan also, and so on down to Iran and so on. Okay, this gives you a sense that if we want to assign historical responsibilities, then we have to consider these numbers as well. Traded CO2 makes little difference to the cumulative total. So China and US still dominate, Russia, Brazil, Indonesia, so the ranking remains almost the same in terms of cumulative emissions, imported CO2 and exported CO2. So you have to be careful about that, even though it depends on whether you do it cumulatively over time or just 1990 onwards and so on. So annual total emissions, looking at it again, we have already looked at it before. Obviously they started increasing after the Industrial Revolution, and the regions that are contributing, of course, you have EU 27 and Europe excluding the EU 27, United States. More recently, you can see how the evolution happens here. More recently, China is beginning to dominate, Asia excluding China and India, and then other regions like Africa, South America, and North America, excluding USA, and so on. Okay. Obviously, these are good to keep in mind and good to track, because all the negotiations are going to always invoke some kind of compensation or delayed action or some kind of accommodation for equal but differentiated responsibilities is kind of the phrasing that's used for climate action between different countries. So here is annual CO2 emissions from the burning of fossil fuels for energy and cement production as a map. So here we are per year. This is from year 2014 or 15, somewhere. It's a few years old, but it doesn't matter. The relative ranking is still the same. China is now the largest emitter, with US being second, and then you have lots of other countries behind. So we need to keep the total emission in mind and decarbonize the entire globe, and not necessarily worry so much about historical cumulative emissions, historical responsibilities, current emissions, because COP26, which is coming up soon next month in November 2021, is going to focus on all these sorts of issues, and every country is being put under great pressure to explicitly state their net zero targets. How does it matter? Well, as soon as countries are announcing their net zero targets, the year when they will hit net zero and so on, they have to give details on how they will do it, and then there will be so-called monitoring, reporting, and verification processes that try to see if countries remain on target. Just to look again, imported or exported CO2 emissions per capita here again in 2016. We have looked at this before. So negative numbers where emissions are being imported, and positive numbers where emissions are being exported. So the CO2 emissions embedded in trade measured as net import-export balance in tons of CO2 per capita. Positive show net importers of CO2. So I said it the other way. So if China is manufacturing in something and it's exporting, then US is importing the emission from China, and so on and so forth. Okay, so obviously we are repeating some of the points, but it doesn't matter, because we just need to keep track of the relative boxes in which these categories of emissions fit in. We've been looking at various ranges of emissions, and now we are in greater than a million. I don't remember now where we are, maybe 100. I think we are in the greater than million ton CO2 equivalent category. Okay, just be sure to keep track.